Hi-oh. Hey, Foxtrot couldn't do it, but you can. The calculations involved in projectile motion. This particular problem that Foxtrot is looking at, you can do. I would recommend you trying it after all is said and done. Here we go. Start off with the basics. We know that objects fall at the same rate. We know that regardless where they are along the narrowing path, they're going to fall with this relationship. So the example here, what about by B? Well, you plug in the 2 seconds for right here, and don't forget G is 10, and you solve it. And of course you get 20. We could do that for C, point C. Instead of 2, we would plug in 3, and you would get 45. Plug in 1 at A, and you would get 5. Try it, make sure it works out. So we have a cannonball fired at a horizontal velocity. Let's take a look at this. What's the range of the cannonball? This is more of a review. There's the range is the horizontal distance. And I have for you the formula dx. X means in the x direction. So the distance or range in the x direction. And since we're talking about the x direction only, we have to use things dealing with the x direction. Likewise, from the previous problem, we talked about the y direction, the distance vertically. So we have to use things specific to vertical motion. Time happens to work for both of them, right? It's in the air for the same amount of time that's going horizontal as it is falling. When it hits the ground, time stops for both. And last time I checked, gravity accelerates things vertically. So, back to this problem, this simple formula. We know the velocity, the horizontal velocity. Plug it in here. We know it's in the air for 3 seconds. Plug that in there. And of course, 30 times 3 is 90. It went 90 meters. Pretty easy. So keep that in mind. You're going to need that for the very last problem today. So let's say we have Danger Dan. He's fired at an angle of 35 degrees. And there's a muzzle velocity of 25 meters per second. Remember, muzzle velocity is the velocity at which he leaves the gun. Immediately, we can break this into its components. We know that 25, to go at that velocity, it has a horizontal and a vertical velocity. And this particular question is, what's the vertical velocity? Well, that would be this side. And this looks like a sine problem. The sine of the angle is equal to the opposite side, or the y, over the hypotenuse. So the sine of the angle, which is 35, is equal to our unknown y side, divided by the hypotenuse, which is 25, and we will get 14.3 meters per second when we plug that into our calculator. You know what's coming. How about the x component, the horizontal velocity? This one. We know this was 14.3. Well, this looks like a cosine problem for the x. The cosine of the angle is the adjacent side over the hypotenuse. So the cosine of 35 is equal to the adjacent side, that's our unknown, divided by the hypotenuse, which is 25. And when you solve that, you should get 20.5 meters per second. All right, so we know the two velocities. Now we can solve for anything, any part of this motion that's vertical or any part of it that's horizontal. Remember, if it's asking for vertical things, we have to use vertical. If it asks for horizontal things, we have to use horizontal velocities. So Danger Dan we want to know what's his entire time of flight. How long is he in the air for? Well, if you remember our very first problem, we figured out how long it takes for something to fall. Well, let's put this together. We have a formula that we developed in class, and it's the time of flight is 2, and the reason is because it's in the entire time to go up and down. If we just do it 1 times 1, it's just like dropping an object. So it's 2v in the y direction divided by acceleration. In this case, the y direction is acceleration due to gravity. This really has its origins from the acceleration is the change in velocity over time. You can solve that. And this just gives you one direction. We need to know it in 2 directions, up and down. So we need to multiply it by 2. Well, we know the velocity in the y direction is 14.3 from a previous calculation. We know g is 10. Remember, we use 10 because it's an easy number instead of the 9.8. And, of course, you should get 2.86 seconds when you type that into your calculator. So we know the time of flight. How about the range? How far did he travel? Well, that's pretty simple. Remember, we did that already. And since we want to know a horizontal thing, we need to use horizontal other things. And of course, we know the distance in the x, in other words, the range, is equal to the velocity in the x times time. We know it took the 2.86 seconds. We know we solved for that the horizontal velocity was 20.4. When you multiply those two together, you get 58.63 meters. Congratulations. You can do it. Try to go back. See if you can figure out what Foxtrot couldn't.